like an hour and a half in, that this is a pretty straightforward graph? What's the only change we see on this graph? Oh, pardon me? Yeah, so it's a vertical stretch, right? So we can expect the graph to be a little steeper, and sure enough it is. Like, look at this graph compared to the very first graph we saw over here, I think, right? The very, very first one we were exposed to, it's sort of a shallow graph, and this is a little steeper. So it's increasing. The y-intercept is 2, and that's because of the vertical stretch, right? There was no horizontal asymptote other than 0, right? If there's no number here, it's a plus 0, meaning the horizontal asymptote is 0. Domain is negative infinity, positive infinity. The range is 0 to infinity. I used my key point 0, 1, 1, and 3. And I just noticed there was no change on the x, and I just had to multiply every y by 2. That only gave me 2 points. But with my 2 points and my asymptote, and because I know the shape of an exponential graph, it was quite easy to graph. Agree? That one? Okay, this is the one we did together. So we should have that one. Then this was the next one. I think this was a tricky one, right? Because of the e. It's not quite as easy to think with e as a base because it's 2.7, right? It's a decimal number, but I just want you to have that number in your mind, that it's a number that's almost 3, right? There is another vertical stretch and a horizontal shift to the right by 1, right? So that would change my key point 0, 1, 1e to, I'd have to add 1 to the x's if they shift right and multiply by 2 the y. So that gives me 1, 2 and 2, 2e, which is about 4.14, right?
No, 5.4.
Is it? Thank you. 5.4, thank you. Oh yeah, 27 is 54. Okay, so this point has to be up a little bit. So when I graph those 2 points and my horizontal asymptote, which I should sketch in, this is my graph, right? So I have 1, 2 and 2, 5.4, and I had to go off the grid a little bit, right? 1, 2, 3, 4, 5, and a little bit. Okay? Sorry about that. Right, now the y-intercept. It asked us for all the info, right? So increasing no x-intercept, y-intercept of 0.74. Agreed? And so my y-intercept, actually it should be a little lower too, shouldn't it? Sorry guys, screwed this graph up. There. How many people got this as a y-intercept? All right, how did you get it as a y-intercept? Yeah, just like you always do. Nothing ever changes, right? Replace x with 0 and solve for y. 0 minus 1, and we just simplify. So y equals 2 to the e negative 1. Your calculator should be able to, you should be able to type this right into your calculator like that, right? Some calculators are easier than others. The calculators that when you press E gives you the little caret, the little exponent symbol, those are nice. The graphing calculators are not great. Well, actually yours is easy, Jack. The calculator that I have is kind of difficult with ease. But if you can't get this on your calculator, let me know, okay? And then the last graph had the most changes, I think, because it had a reflection, a vertical compression, and a vertical shift up. What does the vertical shift up do for you? What do you immediately know? Yeah, horizontal asymptote, y equals 2. So that's really nice to know right away because that's a guideline for our graph. This ended up being a decreasing. So the equation of the asymptote is 2. My key points were 0, 1, 1, and 3. So the math that I had to do, x stayed the same, but I had to multiply y by -1/2 and add 2. That gave me 0 and 1.5, and 1, -1. With my asymptote, I realized that this is a graph that's going to grow downward, so it would be decreasing, and that's my domain and my range. Okay? Questions about that? I'll post these on the blog too. So that's your intro to graphing. Pretty straight. What's up, Eduardo? Did I goof? 1, negative 1?
Yeah, because if you take 3, take half of it, that's 1.5 plus 2, right? That's negative 1.5, right? Plus 2, so it'll be positive a half. You know?
Oh yeah, negative 1.5 plus 2, positive a half. Wait. Okay, negative 3 over 2 plus 2. Oh yeah, it is positive a half. Sorry, thank you. Eduardo corrected me. It's positive a half, right? Yes. Okay, so I think my graph still looks the same, right? I don't know what I was doing today. 1 is a half? Okay. So it'll just be a little, thank you. It's still going to be decreasing, right? Okay, so would you agree with me? This is a pretty simple graph, right? Do you think you can get by with 2 key points and an asymptote to graph? Hope so. You'll see that the logarithmic graph is quite easy as well, because it's just the inverse of an exponential. What does the inverse of a graph look like again? Do you remember what our rules are for the inverse of a graph? Remember that?
Just switch the x and y value.
Switch the x and y value. So what graph or what line does that reflect over? It reflects over this one, right? Agreed? Yeah? So, remember our y equals x? That's our the graph that we reflect inverses over. So if I tell you, if I give you an exponential graph, let's say I give you this graph. This is your exponential graph. This point is 0, 1. And this point is, I'll give you one more point. 1, 2. Okay? So you already know what the exponential function is. Y equals 2 to the x. What would the inverse graph? How would you graph the inverse graph?
1, 0.
Just take those 2 points and flip them, right? So let's do that. So I have a graph, instead of a y-intercept of 1, I have an x-intercept of 1, right? Guess here. So this would be 1, 0. And then I'd have 2, 1 here, right? I have this point and this point. Okay, think about this. If my old asymptote was horizontal at y equals 0, my new asymptote will be vertical, right? So this time it's the x-axis. So this is what the inverse of a, this is what the inverse of an exponential looks like. Looks like an inverse, right? So this is the exponential function, and this guy is the log function, just the inverse. Okay, so we'll talk a little bit about that tomorrow. But before I send you off, I'm going to get you to look at 7.2, and the first part's really easy. They actually don't ask you to graph. If you want to graph, by all means do some graphing and you can check yourself on Desmos. It just says describe how the graph of the section compares to the first. So what does describe mean in our vocabulary in Fortius Pre-Cal? Use words. So describe and explain means use words. Now, they expose you to some applications right away, which isn't a bad thing. We usually leave our applications to the end, but I kind of like that they've introducing some applications here. So again, the first application question involves money, because money grows exponentially if we're using compound interest, which in Canada we do. I'm actually going to give you the compound interest formula though. That's all I'm going to do. I'm going to give you the real formula, and so the variables will be a little different from what they use. Looks really big, but okay, so I'm going to actually scratch these out because they've used different variables, so I'm going to scratch this out. Has anyone seen this formula before? The compound interest formula? Yeah, Jack and Neville. Ryan, you might have seen it before, right? No? Joanna? No? Because sometimes there's some questions that pop up in pre-calc. Okay, so this is how money grows. I'm going to give you all the parameters. A is the final amount. This is the formula you'll see on the exam if they have a compound interest formula or in another math course. P is the amount you start with, the initial amount. So if you had some money lying around and you had it invested in a bank account, you could use this formula to figure out how much money you'd have in like 5 years or 10 years. 1 is just 1. R is the interest rate. But we have to be careful as a decimal number only. As a decimal's only number. Anyone know what I mean by that? No? Okay, let's keep going. N and T. What do you think T stands for? Time, right? And that's in number of years. Now, N stands for the number of compounds per year. If it's, the question will always have the word compounded in it. If it's compound interest, and like I said, in Canada, in North America, in most Western civilizations for sure, and actually worldwide to be honest, compound interest is used. That means that your money, whatever you earn on interest, that interest gets added to your initial amount. It just keeps growing and growing and growing, right? Compound interest is great if you have money to invest, but it's not great if you borrow money, right? That's how people get into credit card debt easily because of compound interest. So right after, in any money question that involves compound interest, right after the word compound is another word. That word tells you what N is. How many times a year would something happen if I said annually? 1, right? So that tells me N is 1. Okay? So all of these are very complicated, but it's a complicated formula. A is the final amount. And so you just plug these variables into this formula and you should get your answer. You're looking for A, right? These two questions go together, by the way. Okay, so you've actually done this one because they just asked for a formula. You're going to use this formula to solve for number 3. They're asking for the final amount. You have the initial amount. You know what R and N is. Notice N appears twice. And then T. This is a complicated exponent too, right? Because it's got 2 parts to it. What does what does NT mean? Times. So you have to times those 2 numbers together. All right. Just another quick, we'll go more through this when we do more applications, but other common compounding words. How many of you have bank accounts? Lots of, you probably might have like a savings or checking account, right, for your ATM. It probably says compounded daily. That's a good thing. Daily means every day they go and adjust your interest and they add interest to your account daily. So compounded daily, that's common. Annually, we always talked about monthly, weekly. I think that would be semi-annually. Okay, so let's say I use these instead of annually. What would N equal in all these cases? If I said daily, 365. If I said monthly, what? Weekly, 52. What does semi-annually mean? Twice. And then one more. Bi-weekly. Some of you may get paid this way too. Bi-weekly is 26. Okay? So those are all the words that might, adjectives that might pop up in a money question. Okay, so I've given you all the info. That should help you do 2 and 3. There is a kind of a technical formula to do 4 and 5, but I don't want to do that. I just want you to play around with number 4. It's an exponential equation. You could actually do this just by kind of a trial and error. You could actually make a table of values even for this and figure this out. A bouncing ball rises 60% of the height from which it fell. If the ball fell from a 10-meter height, a 10-meter balcony, express the height in meters as a function of bounces, and after 8 bounces, how high is the ball? So see if you can get that one. What that means is, when something, or even, you know when people jump off a bridge on a bungee cord, what happens? They bounce, and then they bounce again, but they don't bounce as deep, right? And then they eventually stop. Same with a bouncing ball, right? When you drop it, it's going to have one big bounce. Then it's going to have a smaller bounce and a smaller one. What that means is that from its first big bounce, the second bounce will only be 60% as high as the first bounce. Then the third bounce is 60% at the second bounce, and on and on and on, right? That's an exponential equation, because that 60% is constant. Every bounce is 60% of the previous bounce. When you have a constant rate like that, that's an exponential function, right? Same as the money question. Why this is exponential is this inside piece here represents the base, right? It's a constant. The amount of money is going to change, but that it'll keep going at that constant rate until you take it out of the bank, right? Now, one more thing I want to address. What do I mean by the interest rate as a decimal number only? What's the interest rate in this question? Read it again. What interest rate is the bank giving this person? 5.75%, right? Which is a lot. That's actually pretty good. Now, that's a percent number. We have to convert that to decimals only. So, what would that be as a decimals only number? Divide by 100, and you'll get 0.575, right? Because we only use pure decimal numbers in formulas. We don't use percents. Okay? So that's it. Finish those graphs. If you didn't, I'll post the answers, and then try to get through 231. That first part is easy, I think. See you all tomorrow.